Hey there, MSM3. We are starting Unit 2. And this lesson is about rational and irrational numbers. And if you think about the word rational, and it's sort of a language arts term, rational usually means like something that makes sense. It's very logical. Irrational is usually something that doesn't make sense or is not rational. So if you think about that in terms of vocabulary words, that sometimes can help us with rational and irrational numbers. So we're going to fill in the Venn diagrams below to show the relationship between different types of numbers. So our universe is going to consist of what we call real numbers because there are actually imaginary numbers, but we're not going there today. The first set of numbers that were ever sort of named were called the counting numbers or natural numbers. And counting numbers or natural numbers are the numbers that you can count on your fingers, 1, 2, 3, and so on. Natural numbers were used for things like how many cows do you own? How long is something? And they were just whole numbers that were only positive, no zero. So when we get to the next category of whole numbers, this is the one that includes zero. So 0, 1, 2, 3, and so on. Still all positive, no decimals, no fractions, but we've now included zero. And sometimes it's helpful to think of like whole and the O in whole, or the way your face looks when you say the word whole. The next one that we have are integers, and we spend a lot of time talking about integers in 7th and 8th grade math. Integers include negative numbers. So we can say -2, -1, 0, 1, 2. And you'll notice this time I'm going to put dots on both the left and the right because it continues going to smaller and smaller negative numbers, larger and larger positive numbers, still no decimals or fractions. So if we look at sort of the, nicknames maybe, these would be your counting numbers, the ones that we can count on our fingers. Whole numbers includes 0. Integers includes the negatives. And the last one that we have on the outside are called rational numbers. And you'll notice that is the largest circle because the most numbers fit in it out of these numbers that we're talking about. Rational numbers is where it starts to include fractions and decimals. So includes fractions and decimals. So examples would be like 1/2, -2 1/4, 7.5, things like that. So you would have all of the previous numbers, like natural numbers 1, 2, 3, fit under the heading of rational numbers. But since 1, 2, 3 are the counting numbers, the best name for them are natural, but they also happen to be whole numbers and integers and rational numbers. At rational numbers, though, the ones with the fraction and the decimal, I can't call them natural numbers because they have fractions and decimals, which means they don't fit in this category. They don't fit in this category. They don't fit in this category. The only category they fit in is this outermost ring. Now, you've also got this weird little circle off to the side. If rational numbers are all the numbers in this large circle, then over here we have irrational numbers. And irrational numbers are numbers like pi, 3.14, and then it goes ... because it continues, but it doesn't have a pattern, so there's no repeating bar. The square root of 35, if you've ever tried to find square roots of numbers that are non-square numbers on a calculator, they go on forever. Another number is called the golden ratio, and that one is a number that we haven't talked about yet, but it is another number that often gets discussed with irrational numbers. So these are two categories that fall under real numbers. You will notice that a number is either irrational or it is rational, and the two circles do not overlap. Rational numbers are numbers that can be written as the quotient of two integers. Rational numbers include terminating and repeating decimals. So rational numbers, this outer ring, we've got a fraction here. Quotient of two integers is just a fancy way of saying fraction. So fractions count, and 7.5, that could also be written as 7.5, or it could be written as 15 halves. So even though this one is a decimal, it can be written as a fraction or the quotient of two integers. Quotient of two integers means it can be written as a fraction where both the numerator and denominator are integers. So you'll notice when you make it to a fraction, there's no decimals in the numerator, there's no decimals in the denominator. Integers are positive and negative whole numbers. And those numbers also include 0. So integers include 0 the same way that the whole numbers list includes 0. Irrational numbers are numbers that cannot be written as the quotient of two integers. Irrational numbers are non-terminating and non-repeating. So I'm going to highlight that because that's really important. If you look at the very bottom, irrational numbers, the ones that we said not rational or don't make sense, they are non-terminating and non-repeating, which is really fancy for goes on forever without a pattern. So goes on forever without a pattern. All right. So what do we have? What types of numbers? 4. If we look at 4, is it possible to write it as the quotient of two integers? Can I write it as a fraction? Sure. I can write it as 4 over 1. That makes it rational. 0.8. Can I write it as the quotient of two integers? So 0.8, if I read it out loud, is the same as 8/10. Lowest terms would be 4/5. Either way, we know it's rational. -3 can be written as -3 over 1. That makes it rational. Notice that the -3 is an integer and the 1 is an integer. 7/12, already a fraction. I don't have to do anything to it, so it is rational. 4 2/5. I can take that mixed number and make it an improper fraction. 5 times 4 is 20, plus 2 is 22/5, making it rational. 8.5. I can turn that one into 8.5 or 17/2, and that makes it rational. 0.375. It looks more intimidating, but it's 375 in the tenths, hundredths, thousandths place, and that makes it rational. I can put that in lowest terms, 3/8, but as long as you know that it can be written as a fraction, you're good. Square root of 36 is the same as 6 or 6 over 1, so that's rational. Now here we've got a repeating decimal, right? 0.3 repeating means 0.33333, and that is 1/3. That's one of those decimal to fraction conversions we should have memorized. It is rational. 0.09, less common, but the fact that I can see there's a repeating bar over the 0.9 automatically makes it rational, and the fraction is 1/11. Now, 1.232332333, you'll notice that I can't say 2, 3 and just put a bar over it because the next one has more 3s and the next one has more 3s. So because this one is non-repeating, meaning I can't use a repeating bar, that makes it irrational. Square root of 10. If I type this into a calculator, you will notice that it is not a whole number because the square root of 10, 10 not being one of our square numbers, it's around 3.1, does not have a pattern, like non-repeating, does not terminate, so it is irrational. And last but not least, pi. Pi is approximately 3.14, does not have a pattern, cannot use that repeating bar to represent the pattern, and it goes on forever, so it is also irrational. Now, I should be a little bit more specific on the pattern. This one, you'll notice, I could predict the rest of the digits, but since I can't use a repeating bar to repeat the pattern, then it is considered non-repeating. So just to clarify, when I'm saying pattern, I'm referring to whether or not I can use a repeating bar to represent the pattern. The square root of any non-perfect square is irrational. So 0.7 by itself, is it rational? We would say yes. We can write it as 7/10, which is the quotient of two integers. 0.7 repeating, is that rational? We would also say yes. 2 reasons. 1, it can be written as 7/9, or we can say it is a repeating decimal. The fact that it has the repeating bar tells us that it's rational. So 0.707770770, is it rational? We would say no, there is no repeating pattern to use a repeating bar on. Like I can say I know what the next 6 digits are, but I cannot use the repeating bar to represent the pattern, making it irrational. So this one is irrational. All right, see you on class.